All right, today we're talking about mutually exclusive and inclusive events. Two events that have no outcomes in common are called mutually exclusive. They cannot occur at the same time. Some examples would be, well, if you're taking a multiple choice test, you're just guessing, the outcomes of getting number one correct and number one wrong, they're mutually exclusive. You can't get number one correct and wrong at the same time. Drawing a card from a standard deck, the outcomes of ace and numbered cards are mutually exclusive because an ace is a lettered card, and so these two outcomes do not overlap at all. Rolling a die, the outcomes even number and odd number are mutually exclusive. You can't get an even number and an odd number at the same time. On the other hand, two events that have outcomes that are in common are called inclusive. They can occur at the same time, like taking a multiple choice test by guessing. The outcomes of getting number one correct and getting number two wrong are inclusive. You could get number one correct and number two wrong. Both things could happen, just one could happen, but they could overlap. Both things could happen at the same time. Drawing a card from a standard deck, the outcomes of ace and red card are inclusive. There's red cards that aren't aces, but these do overlap. Rolling a die, the outcomes even number and number greater than 3 are inclusive. They share some outcomes. For both mutually exclusive and inclusive events, the addition rule can be applied. So, if you're trying to find the probability of A or B, we're going to see that a lot today. You find the probability of A, the probability of B, and you subtract away the overlap. All right, so we're going to look at each of these probabilities and we're going to decide, is it mutually exclusive, is it inclusive, and we're going to find the probability. So this first one, probability of getting a heart or a numbered card. Well, here's all the hearts, and here's all of our numbered cards. And so we have to ask ourselves, is there overlap? Yes, there is overlap. If there's overlap, that means there is events, there's outcomes in common. So that means this is inclusive. Mutually exclusive, separated. Inclusive means they have outcomes in common. So those are definitely inclusive. So now we find the probability. First, the probability of getting a heart. There's 13 out of 52. We add it to the probability of getting a numbered card. That's 36 out of 52. And we subtract away the overlap. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 52 cards in that overlap. So we add 13 plus 36 is 49 minus 9 is 40 out of 52, which reduces to give us 10/13. So those were inclusive events because we did have overlap. Let's look at this next one. The probability of getting an ace or a numbered card. So there are aces. Here are the numbered cards we were just dealing with. Is there any overlap to these? No. No overlap. They're exclusive. They're excluding each other. Mutually exclusive are these events. So the probability of getting an ace or a numbered card, we still find the probability the same way because we have that word or. We take the probability of getting an ace, which is 4 out of 52. We add it to the probability of getting a numbered card, which we know is 36 out of 52. We subtract away the overlap. There is 0 out of 52 overlap. 4 plus 36 is 40 over 52. And we know what that reduces to. That's 10/13. These are much different problems. Clearly one was inclusive, one was mutually exclusive, but they still have the same probability. So don't be too scared away from that. Moving on to the next one, probability of getting a jack or a diamond. So here's all the diamonds. There's all the jacks. There is overlap, which means This is inclusive. And to find the probability, we find the probability of getting a jack, which is 4 out of 52. We add to the probability of getting a diamond, which is 13 out of 52. And we subtract away the overlap, which is just 1 out of 52. This gives us 16 out of 52, which reduces to give us 4/13. Final one here, the probability of getting a lettered spade or a lettered diamond. So a lettered spade would be the ace of spades, jack, queen, king of spades, or getting a lettered diamond. A lettered diamond would be the ace of diamonds, the jack, queen, king of diamonds. Notice that these are not overlapping. These are certainly mutually exclusive. Probability of getting a lettered spade, there are 4 out of 52. We add it to the probability of getting a lettered diamond, which is 4 out of 52. We subtract away the overlap. There's no overlap. And so our probability is 8 out of 52, which is 2/13. All right, we can also find things on a Venn diagram. So here we've got some made up information. We surveyed 25 people. We said, where will you apply to college? We had Georgia Tech responses, Georgia College responses, UGA responses. Some people responded to multiple of these things. So there is some people, like 5 people, said they're applying to UGA and GCSU, but not Georgia Tech. 4 people said none of them. All right, so we've got some information to work with. The probability of getting, or of the probability of talking to a person, finding a person who is saying they're going to go to both, or they're going to apply to UGA or Georgia Tech. Well, the UGA bubble. Here's our UGA bubble. Down here is our Georgia Tech bubble. Do we have overlap? Yes, because we have overlap, these must be inclusive events. And so next, we find the probability. Well, the probability of talking to a UGA person, well, look at in the UGA bubble there, 8, 1, 3, 5, there's 17. 17 in that UGA bubble right there. So the probability of finding a UGA person would be 17 out of 25. We add it to the people in the Georgia Tech bubble. That's 7 out of 25. And we subtract away the overlap. The overlap is 4. So 7 plus 17 minus 4 is 20 out of 25. That's 4/5. If you just randomly talk to one of these 25 people, there's a 4 out of 5 chance that they applied to UGA or Georgia Tech. Most of these people applied to either Georgia Tech or UGA. Second one, the probability of not applying to any of the colleges or GCSU. Well, not applying to any of the colleges is out here. Applying to GCSU is right here. Is there any overlap? No. So these are mutually exclusive. Well, to find the probability of this, we find the probability of talking to someone that didn't apply to any of the colleges, which is 4 out of 25. We add it to the GCSU bubble, which has 9 out of 25 are in that bubble. And we subtract away the overlap. We know there was no overlap, 0 out of 25. And so this comes out to be 13 out of 25. There's a 13 out of 25 probability of talking to someone who didn't apply to any of them or did apply to GCSU. Next, not applying to UGA or GCSU. Well, not UGA is everything outside of the UGA bubble. Not UGA consists of all of these numbers. That's everything outside of the UGA bubble. Or GCSU. Well, there's the GCSU bubble. So, first off, is there overlap? Oh yeah. There's not UGA and GCSU overlapping, so these are definitely inclusive. So before we get confused about, oh, this is a very confusing probability to find, you just follow the formula, okay? So don't get confused about it, just follow the formula and it'll make sense of it for you. You take the probability of a not UGA person, that's 8 out of 25. We add it to the GCSU bubble, 3, 5, 0, 1, that's 9. We subtract away the overlap. Here's the overlap, that 0 and that 1, so that means there's one student that overlaps. 8 plus 9 minus 1 is 16 out of 25. We can't reduce that. That is our probability of finding someone who did not apply to UGA or applied to GCSU. The probability of not UGA or not applying to any of them. Okay? So not UGA. Again, we just dealt with that. Here's all the not UGA. Or not applying to any of them. Well, not applying to any of them is just that 4 out there. So do they overlap? Absolutely. So these are inclusive once again. And so to find the probability of this, we find the probability of not UGA, 4, 3, 1, that's 8 out of 25. We add it to the probability of not applying to any of them, which is just 4 out of 25. We subtract away the overlap, which is 4 out of 25. And we're left with 8 out of 25. Finally, not Georgia Tech. Not Georgia Tech would be all of these numbers outside of the Georgia Tech bubble. Or not GCSU. Not GCSU would be all of these numbers outside of the GCSU bubble. And so to find the probability of this, we can first notice there is overlap. So it's inclusive once again. And to find this probability, we take the probability of not Georgia Tech, which was red. Not Georgia Tech is 12, 17, 18 out of 25. We add it to the not GCSU. The not GCSU is circled blue. So that's 12, 13, 16 out of 25, and we are going to subtract away the overlap, which is that 12 out of 25, the ones we circled twice over there. 16 plus 18 is 34. Subtract away 12. This gives us 22 out of 25. Can't reduce, so we leave it the way that it is. That's our probability.